Matter is everywhere. Everything is made of matter. This lava lamp is matter. These Lego bricks are matter. The different liquids inside of these beakers are also matter. But how can we tell which one is water? Let's find out together in this episode all about the chemical properties of matter. A property of matter is simply any characteristic that we can use to describe it, like how it behaves, looks, or feels. A physical property is a characteristic that can be observed or measured without changing the chemical makeup of a substance. For example, identifying that the three substances in front of me are liquids is a physical property. You can learn more about physical properties in this video. A substance's chemical properties are a little harder to determine than its physical properties. A chemical property is the ability of a substance to change its composition to produce new substances, meaning at the atomic level, you end up with a different substance than you started with. So chemical properties can only be observed once the chemical composition of a substance changes, or if what you're observing is a chemical reaction. Here are some indicators that a chemical reaction has taken place. And if you need a refresher on physical and chemical changes, this video should help. Today, we will be looking at reactivity, flammability, pH, and oxidation of substances. These are all chemical properties and can be observed during chemical reactions, where bonds break and form, creating different materials. Who knows? Maybe we will discover which one of these is actually water. Reactivity describes how likely it is for a substance to react when it comes in contact with another substance. Simply put, it is the tendency to chemically combine with other substances. When matter reacts, it changes into a new kind of matter, and typically, energy is released. These reactions can be extreme, like the most reactive elements in compounds igniting explosively. Some can even burn in water. Other reactions can be less impressive and may only cause some bubbling or a slight color change, like these bananas. For example, the metals at the end of this sparkler are highly reactive. When they come in contact with an ignition source, like this lighter, they change into new substances, releasing heat and light in the form of sparks. Most importantly, reactivity boils down to atomic structure. Each element has a different atomic structure. Some elements are always looking to give away electrons, while others are looking to gain them. These are the more reactive elements. Reactivity increases with the ease of accepting or donating electrons. Let's take a look at a painfully simplified example. Imagine that you are a mystery element and that you are holding on to just one outer electron. It's annoying. You're spending energy trying to donate this one and bond, and then finally relax. And then you come across another mystery element with room for just one more outer electron to be full. They're really wanting to get this outer electron bag full, so they aren't spending energy on it anymore. The two meet and react. Mystery element A finally doesn't have to worry about that one outer electron, and mystery element B finally has that full outer electron bag and can relax. They've bonded to form a new mystery substance, happier and more stable. That's really it. Sort of. Let's take a look at one of my favorite chemical reactions, the one that makes glow sticks glow. Glow sticks are made of two separate parts. There is an outer tube and an inner tube. I'm doing this so you don't have to. Inside the outer tube is a clear liquid, hydrogen peroxide. Inside the inner tube is a substance called diphenyl oxalate mixed with a dye. When you crack a glow stick, you're really cracking open this inner tube, releasing the diphenyl oxalate. Once the substances combine, there is a chemical reaction, producing energy. That energy reacts with the dye and emits photons of light, creating the glow that you see. If you're still here, liking this video, let us know. And Hit that subscribe button so you never miss an episode. Another chemical property is flammability, or the ability of a substance to ignite and sustain a fire. Time to narrow down our liquid-filled beakers. These beakers hold isopropyl alcohol, vinegar, and water. Which of the three do you think is flammable? Let's find out. There is a reaction between the oxygen in the air and the alcohol. We call that reaction combustion. When a material burns, it undergoes a chemical change, reacting with the oxygen to produce heat and light. This substance is volatile, meaning it turns into a flammable gas or vapor at room temperature. When the flame touched these vapors, the molecules reacted rapidly with the oxygen in the air. The vapor is what is burning, not the liquid. For combustion to occur, certain conditions must be met. First, there needs to be an ignition source, like a flame or even a spark. And there needs to be enough oxygen present. How easily a substance ignites and how intensely it burns are the main factors in determining its flammability. Toxicity is another chemical property. A toxic substance is one that is harmful to living organisms and cells, all living organisms. Toxicity is the level of harm a toxin can cause. Different chemicals have varying degrees of toxicity. For example, only a small amount or a short exposure to a substance with a high toxicity would be harmful. In contrast, a substance with low toxicity needs a higher dose or a longer exposure for it to be harmful. It's still toxic and harmful, but just to a different degree. Even the substances that we think are safe can be toxic in very large amounts. pH is a measure of how acidic or alkaline a solution is. It's an indicator of a substance's chemical behavior affecting reactions and interactions. You can use universal indicator paper like this to identify the rough pH using color change chemicals. We can use this to identify the liquid in the other two beakers. We know that beaker A had the isopropyl alcohol because of its flammability. Now we have water and vinegar left. Vinegar is an acid and water is neutral on the pH scale. So let's test. This liquid looks like it's at a 3 on the pH scale, and this liquid is at a 7. That would make beaker B the water and beaker C the vinegar. Oxidation is typically an example of slow reactivity in metals. Oxidation is the loss of electrons by an atom or compound, resulting in a change of properties. Oxygen is an oxidizing agent, a strong oxidizing agent, but oxidation does not always involve oxygen. It does most of the time, but not always. Not always. Some metals like iron and copper have a chemical reaction with the oxygen and water in the atmosphere to create a new kind of matter. The original color of the Statue of Liberty wasn't this iconic green. The statue is made of copper sheets, meaning before oxidation occurred, Lady Liberty looked like a shiny new penny. Iron reacts with oxygen in the air to corrode, producing rust. Corrosion is an oxidation process. We can speed up this process here by burning this steel wool. Before the reaction, this scale shows that the mass of our steel wool is 19 grams. So let's see what happens. The steel wool is gaining mass as it burns because the iron in the steel rapidly reacts with oxygen from the air to form iron oxide, or rust. The added mass of the gained oxygen atoms makes the compound heavier than the original iron. So the next time you crack a glow stick or see that iconic green on the Statue of Liberty, think back to the chemical properties that make it all possible. And if you want to learn more science, you can check out this video next.